This is a solution to number 7 from the practice problems from note 6.1. So this is a really good problem to practice converting from degrees, minutes, seconds to degrees and then to radians in an arc length problem. So we're told the radius of the Earth is approximately 4,000 miles. So here I've drawn a circle to represent the Earth, actually a cross section of the Earth. And we're given the latitudes of two cities. So Miami is at 25 degrees, 46 minutes, 37 seconds. And Washington, D.C. is at 38 degrees, 53 minutes, and 24 seconds. These latitudes are the angles in degrees, minutes, seconds, right? These are in degrees, minutes, seconds, above the x-axis or north of the equator. So I'm going to sketch these angles. So Miami is at 25 degrees. So I'll put Miami is about here. This is Miami, and its angle is 25 degrees, 46 minutes, 37 seconds. And then Washington, D.C. is at 38 degrees, 53 minutes, and 24 seconds. So that's a little bit north of there. So let's say this is Washington, D.C., and its latitude is 38 degrees, 53 minutes, and 24 seconds. So that represents, that's the angle for Washington, D.C., and the angle for Miami is this smaller angle here. And we are asked to find the distance between the two cities. The distance between the two cities is going to be the arc length on the sphere that represents the Earth, and the theta that we need is the angle that I drew right here, which is going to be the difference in the latitudes between Washington, D.C. and Miami. So eventually we're going to say that S is equal to R theta, and here the angle must be in radians. Okay, the angle that we want is the difference between the two latitudes. So we're going to want to subtract 38 degrees, 53 minutes, and 24 seconds. We want to take that and subtract 25 degrees, 46 minutes, and 37 seconds from that. So this is, the 38 degrees is Washington, D.C., and the next angle is the latitude of Miami. And if we take the difference of those two angles, we're going to get theta. Okay, but these are given in degrees, minutes, seconds. So we need to convert these to decimal degrees. So I'm going to do that by hand without using the conversion in the calculator. So we have 38 degrees plus 53 minutes. And then we're going to multiply that by a conversion factor to get to degrees. So we know that there are 60 minutes in 1 degree. So this is going to convert the 53 minutes into a decimal representation in terms of degrees. And then we need to add to that, we're going to convert the 24 seconds. So 24 seconds, and then either you can do two conversions or you can just say there's 3,600 seconds in 1 degree, and then the seconds cancel out. And that's going to be the angle for Washington, D.C., the latitude as a decimal. And then we're going to subtract from that, I'll do Miami down here, 25 degrees plus the same conversions. 43 minutes times, there's 1 degree per 60 minutes, plus 37 seconds times 1 degree over 3,600 seconds. And if you enter these into your calculator, you'll get this is 38.89 minus 25.7769. And just leave these values in your calculator. It turns out to be 13.11306, I think, degrees. But we need to convert that angle into radians. So we have 13.11306 degrees times our conversion factor is 180 degrees per pi radians, and I'm going to put the 180 degrees in the denominator so I can cancel out the degrees in the numerator. And if we multiply that out, we get that this angle is 0.22865 radians. Okay, that's the angle that we need. So that's this angle right here that we want. And now we're going to go ahead and put this value, the converted angle in radians, into the arc length formula. So we're going to go back to our arc length formula, that S is equal to r theta. The radius of the Earth is given in this problem to be 4,000 miles, so that's going to be 4,000 times our theta in radians, 0.22865, and that's going to turn out to be 915.5. The units here are the same as the radius, miles. So there are 915.5 miles between Washington, D.C. and Miami.